So let's discuss this. What is tan inverse x plus tan inverse y? So if you have been through the literature, you might have seen this big formula, right? That tan inverse x plus tan inverse y is this whole thing. So I will take you through how do we get this. So before that, let's get some things straight. Okay. First thing is, if I define a function, okay, tan inverse of x, what do we know about this? What is the range and what is the domain of this function? So what do you think? The range is the complete real line, the domain is the complete real line, okay, and what is the range? The range is the interval, open interval, pi over 2 to pi over 2. And how do we define this function? We restrict the domain of tan function to define this inverse. And how does this function looks like? This looks like that if this is your point pi by 2, here you have negative pi over 2, and here you have a horizontal line, these are asymptotes of the function, then your function looks like this, right? Okay. Now another thing to discuss is what? Number one, that what is tan of tan inverse of x? So this is equal to x. So a function and its inverse work as an identity function provided this x is in the domain of tan inverse, right? And just now you said that domain of the tan inverse is complete real line. So what do you have? This is x, okay, for all x, real line. Is the other way also true? The answer is no. It's slightly more than what we want, because if I do this tan of tan inverse x, now again x should be in the domain of tan, okay. Which domain? The domain in which you have defined the inverse function of tan, right? And what is that domain? Okay, remember when you were defining tan function, you have restricted your domain from negative pi over 2 to pi over 2, so that it inverse exists, right? Your function is 1 1 and your inverse exists. So this is equal to x only when your x belongs to this interval, negative pi over 2 to pi over 2. If not, then you have to shift then accordingly so that you get the argument in this domain. For instance, if you are at this pi by 2 comma 3 pi by 2, okay, so you are going to get x minus pi. Similarly, if you move ahead a little, 3 pi by 2 to 5 pi by 2, you move a little more ahead saying it is x minus 2 pi. And if you move a little before that, because this is a little different theory which will again need an entire session to explain it to you, like 10-15 minutes. So this will be x plus pi, okay. Presently I assume that you know this, okay, just to refresh. And if I really want to see this in a graph, okay, I can draw the graph of tan inverse tan of x, okay. So if I draw the graph of tan inverse of tan of x, okay, this is y and this is your x. It looks like this, okay. Y is equal to x, just now you said, right? This y is equal to x when you are from negative pi over 2 to pi over 2, right? And otherwise what? It is x minus pi when you are from pi by 2 to 3 pi by 2, okay. So it is like this. So you are from pi by 2 to 3 pi by 2. This is what? This is pi, this is 3 pi by 2, and this line is x minus pi. Similarly, you can keep on getting the same slope lines like this, and even this side, okay, I mean slope are same like this. Okay, so doing these two things, now we get back to our original question. Okay, we want to prove this. Okay, now what does it says? It says that it is equal to the natural, the natural way it should look like this, because I know what is tan A plus tan B, right? So it should look like this, but it says that it only looks like this when xy is less than 1. What does that mean, xy is less than 1? So this is my curve, xy is equal to 1, right? This is my curve, okay. And xy less than 1 means what? All the region here, okay, between the two, okay, between the two, in the sense all this region. If you have the 2 points, okay, any 2 real numbers x and y which lie in any of these yellow region, then you have this, that tan inverse x plus tan inverse y is tan inverse x plus y upon this. But in case you have any other point, let's say if you have here, okay, if you have a point here, this is being followed. Can you see x is greater than 0, y is greater than 0, x, y is greater than 1. Okay. In this region, you are going to follow this, and in the other one, you are going to follow this. Okay. Any point if I give you here, you are going to follow this. Yes. Okay. So that was the graphical description and all the basic stuff. Okay. Let's move on to proving what we have here. Okay. It's not difficult at all. Okay. Just be with me. It's interesting actually. So let's see. Number 1. Okay. So what do you want to find? We want to find what is tan inverse x plus tan inverse of y. Let's assume, okay, let's assume that this is some alpha and this is some beta. So just now what did we say? We just said that the range is negative pi over 2 to pi over t. So your alpha belongs to negative pi over 2 comma pi by 2, and so does your beta, right? Beta also belongs to negative pi over 2 to pi over 2. Great. Now what do you want? You want alpha plus beta, right? Throughout I am not going to refer now that we want tan inverse x plus tan inverse y. I am going to refer that we want alpha plus beta value. Okay. So let's see what is alpha plus beta. Okay. So let's take a tan of that so that we get something out of it. Tan alpha plus beta. Before that, what is, if you have assumed that this is your alpha, what is your x? I can take tan on both sides, right? So I get x is tan alpha. I can again take tan on both sides. I get y is equal to tan beta. Now use your normal formula, tan alpha plus beta. Tan alpha plus tan beta upon 1 minus, everyone knows, right, this formula. Okay. Now let's substitute the values. What do we have here? This is x plus y over 1 minus xy. Perfect. Okay. Now what do we say? We say that I don't want tan of alpha beta, right? I just want what is alpha plus beta. Okay. So we will say, okay, let's come down. If I want alpha plus beta, I have to take tan inverse on both sides, right? So if I do that, if I do tan inverse of tan of alpha plus beta, okay, what do I get? This is tan inverse x plus y over 1 minus xy. Let's call this 1. Okay. Now, what's the issue then? The issue is that tan inverse of tan is not always, tan inverse of tan of x is not always x, right? It is x only when your alpha plus beta belongs to the interval negative pi over 2 to pi over 2. If, okay, if this happens, then you can clearly say that your alpha plus beta or tan inverse x plus tan inverse y is this. Now the question is, how do I ensure that? Okay, when is my alpha plus beta here? One thing is very simple over here. Okay, if I want to ensure this, how? That I just take alpha to be let's say negative, okay, and I take beta to be positive, not a problem. Now can you see, where is my alpha plus beta? The lower values negative pi over 2, higher values plus pi by 2. Okay. So your alpha plus beta will be definitely in negative pi by 2 to pi over 2. Okay, what does that mean? That means if you are taking alpha to be here, okay, that means you are assuming that your x is what? X is negative, right? Your x is negative. Here you are assuming what? You are assuming your y is positive. Okay. Then if your x is negative and y is positive, okay, remember what is your x? X is tan alpha, right? If your alpha is negative pi over 2 to 0, your x is negative, okay, y is positive. So then you have that alpha plus beta is here. Doesn't matter, right? You could have taken alpha in 0 comma pi by 2 and beta in, so, or you could have taken your x to be positive and y to be negative, not a problem. Okay, either this or that. In both cases, your alpha plus beta is in this interval. What does that mean? This or this, that means both are of opposite signs. Okay, so number point A, if the product xy is less than or equal to 0, it's simple, right? That tan inverse x plus tan inverse y, okay, that means your alpha plus beta is this. Okay, tan inverse, it takes time to write this. Yeah, okay, so this. Okay, let's call this some star holds. Now, what's my problem now? So, we said that if they are opposite signs, we don't have a problem. Okay, we can just clearly take tan inverse tan of x is x. Now, what does it strikes to me? It strikes to me that what if both are positive? Okay, so let's check it out. If both are positive, okay, then what? Let's write it. So, again you have tan alpha plus beta is equal to tan alpha plus tan beta upon 1 minus tan alpha tan beta. Okay. Now, if x and y both are positive, that means what? Tan alpha is where? 0 pi by 2, tan beta is 0 pi by 2, right? That means alpha plus beta is what? Where? Sorry, not tan, okay, alpha. If this is positive, that means alpha is in 0 pi by 2. Okay, strictly let's exclude that 0. 0 is already tan. Beta also belongs to 0 pi by 2. Then alpha plus beta is where? 0 comma pi, right? Either you are here in the first quadrant or you are in the second quadrant. Who? Alpha plus beta. Okay. Then alpha plus beta is either in the first quadrant or in the second quadrant. Okay. Now let's check this out. Okay. Still we are not sure, right, which one? Okay, so we have to check this out. Let's look at this. If my x is positive and my y is positive, then my numerator is positive, right? And if I ensure, how do I ensure my denominator is also positive? When 1 minus xy is greater than 0, right? 1 minus xy is greater than 0, or your xy is less than 1. So, I put an additional condition, x is greater than 0, y is greater than 0 and xy is less than 1. Okay, what do we get then? If then numerator is positive, denominator is also positive, right? Because of this condition, you get everything is positive. Perfect. Now, what does that mean? That means my alpha plus beta is positive. Okay, tan of alpha plus beta is positive. What does that mean? That means that either you are in the which? This quadrant or in this quadrant, right? Either you are here or you are here. Okay. This said that either you are here or here, and this says that either you are here or here. Where are you? This, right? First quadrant, because both, according to both, will be satisfied in the first quadrant. Okay. Now again, in the first quadrant, you are, your alpha plus beta belongs to 0 comma pi by 2. That means star holds. What is star? This you just now wrote, right? The same thing holds even when this condition holds, that x is positive, y is positive and xy is lesser than 1. Interesting, isn't it? Let's see when both are negative. Okay, so let's say my x is negative and my y is negative. Where are you if both are negative? That means your alpha is in negative pi over 2 to 0. So is your beta. Okay, alpha beta both belong to here. So where is your alpha plus beta? Either here or here, 0 comma negative pi, right? Alpha plus beta will be belonging to 0 comma negative pi. Great. Now let's see what is my tan alpha plus beta again. Tan alpha plus beta, what do you get? X plus y over 1 minus xy. Now if I am considering xy is less than 1, let's put additional condition, xy is less than 1. My top is negative, this is negative, okay, and what is this? This is positive. Overall you are where? You are negative. Okay, that means tan alpha plus beta is negative. Okay, what does that mean? Saying tan alpha plus beta is negative. That means either you are here or you are here, right? And who satisfies both of that? This fourth quadrant, isn't it? Here. That means you are in the fourth quadrant. Your alpha plus beta is in the fourth quadrant. So your alpha plus beta belongs to where? Negative pi by 2 to 0. Again what? Star holds. Okay, star holds. Because you are in the subset of negative pi over 2. So tan inverse of alpha plus beta, tan inverse of tan alpha plus beta is alpha plus beta. Okay, and this holds. Perfect. So what did you say till now? We just said that doesn't matter what is my x and y, okay, because you have considered all the cases. opposite signs, same signs, till my xy is less than 1, we are good. Okay, if my xy is less than 1, okay, my star holds. Now, the only two cases are left. Okay, we are almost there. Two cases are left. Number one case is that both are positive, but your xy is greater than 1. Then what? Okay. Now, when you are saying that both are positive, that means alpha and beta both lie in 0 comma pi by 2. That means your alpha plus beta is either here or here. Okay, either in the first quadrant or in the second quadrant. Now, again the same old thing we are going to do. Look at what is the sign. Okay, that will be definitely very negative. If you have been with me, you would know that this both is positive and denominator is negative, so this is negative. What does that mean to say? Negative. Negative means either you are here or here. Tan of an angle is negative either in the second or fourth. That means that you are both is satisfying in the second quadrant. That means your alpha plus beta, okay, I don't think this is visible. So, okay, so your alpha plus beta belongs to pi over 2, 2 pi, correct? Here is your alpha plus beta. Now what I need to do? I need to go back, okay, because you are here, okay, because you are from pi by 2 to 3 pi by 2, you are going to give me what? Tan inverse tan of x is x minus pi. Okay, so you are going to give me, if I take inverse on both sides, tan inverse, you are not going to give me alpha plus beta, you are going to give me alpha plus beta minus pi, okay, to adjust it into the actual domain. Okay, so this is tan inverse x plus y upon 1 minus xy, or you can just move this the other side, pi plus. So tan inverse x, this is tan inverse x, right? Tan inverse x plus tan inverse y is equal to pi plus tan inverse this, when you are both are positive but your xy is greater than 1. Okay. Accordingly, okay, if you got the game, then the last one you can do on your own, right? So, but let's finish it off. If both are negative, okay, if both are negative, that means alpha and beta both are in negative pi by 2 comma 0, that means either you are here or here, alpha plus beta is either here or here. And what is tan alpha plus beta? Okay, because top is negative, okay, and also you have xy is greater than 1, 1 minus xy, okay, this is also what? Negative, right? Yeah, correct, this is negative, so overall it is positive. Positive means either you are here or you are here, okay, and that means to say you are actually where? In the third quadrant, okay. That means your alpha plus beta belongs to what? Negative pi, okay, and negative pi over 2, okay. And again go back, okay, if you take an inverse, tan inverse of this, tan inverse of this, okay, you are going to return me alpha plus beta plus pi, okay, because again you want to shift it accordingly, okay, so that you are in the negative pi by 2 to pi by 2 range. So this, okay, or you can just move your pi the other side, okay, or you are going to get alpha plus beta is equal to minus pi plus this, okay. So we have actually proved all of it, okay. So if you go back and see the formula which I showed you in the very first page, we have already proved, okay. So, okay, so hope things are clear. See you, bye bye.